What's up everyone, it's Brace, and this video is a continuation in our Generative UI series. In this video, we're going to be building a whole new Generative UI app, which is going to be deployed on LangGraph Cloud, which is our new cloud offering for hosting LangGraph applications. And because we're using LangGraph Cloud, we're going to build the backend which powers this Generative UI app in LangGraph Python. And then this front end is as the same as other videos. It's written in Next.js with TypeScript. So the reason this video is different from other videos and the way it's more customizable is because here we're going to be using this entire page as our canvas for generating and placing the UI components. In the previous videos, they were all chatbots, so it's pretty predictable where the next UI component was going to have to get placed, and they weren't very dynamic. It was usually, some preset component that would then just get some simple props passed to it and stuck right in as the last message. Here, we're using pretty much this entire UI to generate and place components on. And the backend is also a little bit more complex. So as you see right here, we have this magic filter input. This is going to take a user's input, which is just natural language describing the filter and maybe the way they want the data visualized. Our LLM is going to take that, perform some query analysis on that, and extract different things like the filters it should apply to our orders, the chart type, the way it should render the data on this chart type, and then it's going to actually perform those filters, send it all back to the client, and we're going to render it in real time as each node is completed. So if we see up here, we have this filters and display types pop up. If we click on the filters, we can see all of the different filters that the LLM can select from. So when you're performing your magic filter input, you can use this to kind of reference different filters you want to apply. So let's say we want to filter by state. We could say like filter by California, or we could say filter by orders in California that have a discount. We can use really any combination of these filters we want, and our LLM is going to perform some query analysis and extract these filters. We also have some preset display types. These will map to what you're seeing right here. So they all link to either a bar chart, a line chart, or a pie chart, and it's the preset way that the data is going to be displayed in that chart. So it's either some unique data point for the y-axis or the y-axis and the x-axis. So you can also use these when you're reference when you're performing your magic filter, and the LLM should be able to take what you described in your filter and map that to the proper display type to then render your data. So we can do something like orders by status. Here we see our input, and after it loads, we should hopefully get a pie chart. Yep, and it describes us the name of the display type that it's rendering and gives us a short little description of what this is showing us. We can see we have 51 orders in processing, 37 that are pending, 43 that are shipped, and so on. We don't have any filters here, and that's because this input doesn't really need any filters applied based on the filters that is available to it, right? It's just saying, give me all the orders and show them by status. So it's going to, in this case, it skipped over the filters, didn't apply any filters because we want all the orders, and instead it looked at the pie charts and chose the proper pie chart, or it chose the proper chart to then render the data based on our request. We can also say something like orders after 2023 10/01. So this should use the after date filter. There we go, after date 2023 10/01, and it decided to give us a line chart showing each day and the total dollar amount of orders from that day. We get the description, and we get our chart. So now let's quickly look at LangGraph deploy to see what this trace looks like in the backend, and then we can jump into the code and see how this is written. So if we go over to our LangGraph deploy app, we see this name is GenUI Video. In a little bit, after we finish walking through the code, I'm going to walk you through exactly how you can deploy this yourself and then connect it to the front end and get running. But let's quickly take a look at just what this dashboard looks like. So we see up here, we have all of our revisions. These are like a deployment. When I make a commit, I can add a new revision and it'll redeploy my server with that latest code. We can see some charts, and we have a lot more charts we can access. And then we see all of our runs. So if I open this up, if you're familiar with LangSmith, this should look pretty familiar to you because it's just a LangSmith run, and it shows all of the nodes. So we have our generate filters, generate chart type, generate display format, and filter data node. And then we can inspect each of these runs and look at the actual API call or prompt template call that happened. Okay, so now that we have a high-level idea as to what LangGraph deploy is and what the UI looks like, let's jump into the code and implement our LangGraph Python backend. So if you want to follow along in the code, I'm going to add a link to this GitHub repo in the description. If you've already watched our other Generative UI videos, it's the same repo, but we have a new directory, charts. So this should all look pretty familiar to you, and the new directory is charts, so just pull fresh from main, and you should get that code. Speaking of the other videos, if you haven't seen them, you should definitely go watch at least the intro video as to what is generative UI. It talks about some use cases where it performs better than other traditional methods, and some other high-level things. And if you want to watch the chatbot video where I implement that, I go into a lot more detail in the code as to exactly how we're rendering these components on the UI, generating these UI components, and just a lot more detail into the actual code. Whereas in this video, we're going to be going over the code, but mainly focusing on the LangGraph deploy aspect of it. So if you're following along, you should go to Backend, GenUI Backend, charts, chain.py. And as you can see here, this is where our entire LangGraph chain lives. Right here, we have a diagram which shows our application, kind of a high-level architecture look at our application. You see we have two distinct charts, or sections, sorry. The Python backend, which is hosted on LangGraph Cloud, and then the front end, which is running on the edge or the client, and that's in Next.js. So before we get into the code, let's take a quick look at this. We can see that our backend takes in a user input, which is that magic filter input we saw in the demo, and then it passes that through to some nodes. The first node is generate filters. This node has an LLM. This LLM has a tool bound to it, and that tool has all of the filters, which we also saw in the demo, that it can apply to it. Based on your user input and some other prompting, it then selects some filters to apply to the order, generates those, pass that to a tool output parser, and then we have our final generated filters object. That is then streamed back to the client. This dotted line arrow represents a streaming event. And we're able to extract all these events because LangGraph deploy and LangChain is able to do this. We have this endpoint called stream events, which essentially takes every single event in your app. So in this case, it would be like an on-chain start. When we start this node, anything that happens in here, like an LLM call, that would be streamed back, and then on-chain end, which is when the node ends. That's what we care about. So when the node ends, we stream the result of that node back to the client. And then from there, we're able to map that to different components, like we saw if we look at the demo again. This would be one of those filter components that we got from the first step, and then it renders that in the UI. We stream these events back to the client in order to get a much quicker time to first interaction and continuously update the UI while our backend is working on it, so the user knows that something's going on. And if we weren't to do that, it might take 3 or 4 or 5 seconds to render the final node and render the data. So this way, we just let the user know something's happening, and it keeps them engaged while our backend is working on it. That then gets passed to the next node. As you can see, most of these nodes, or 3 out of 4, are pretty similar. They have an LLM with a tool output parser, and then we get some sort of result which we're updating the state with. So this next node, generate chart type, we bind a tool to it with all the different charts it can select. So in our case, it's bar chart, line chart, or pie chart. It uses some context like the user's input, the filters generated, the different ways it can display data on those charts, and it uses all that to make a decision on what chart to then render. We get the result of that, stream that back to the client, and we render a loading component on the client once we know exactly what chart it is. So if it's a line chart, we might have this loading line chart component, render that in the UI, and then before we've even performed the filters or shown, or we have access to the final data, we can show the user, hey, we have these filters, and we're going to use this chart, and we're working on it. Then we go to the next node, generate data display format, and that selects one of these formats to best render your data based on the filters and the chart type in your input. We update the state and then pass that to the final node, which actually performs the filters on the data using your generated filters and the orders which we passed from the client when this backend was first invoked. That just contains some if-else statements, and then updates our order state with the filtered orders, streams that back to the client, and we render the final chart on the client. Now, let's jump into the code. So we can see at the top of this file, we have our agent executor state. This contains the state that we're going to have available to all of our nodes. You can see these first 3 are not optional, they're required. And that's because these are the fields which we're going to pass in to our backend right when we invoke it. So we have the user input, which is that magic filter input, display formats, which were all the ways it can display data, and then orders, which are all of our fake generated orders that we generate on the front end, and we send it to the backend. These are all optional, and that's because these will be generated in a node. So selected filters will only be generated in the first node, so technically it's optional because the graph won't have access to this field until it's generated in the first node. Chart type generated in the second node, display format generated in the third node, and this fourth node, we're just going to be updating this original filters field and replacing it with our generated filters. If we scroll down, we see this create graph function. This createGraph function returns a compiled graph, which is the type of this when we compile it. And then we have our nodes. So we have our generate filters, generate chart type, data display format, and filter data node. Those all match up here. And then we're not doing anything complex with this LangGraph graph. We're just passing each node to the next. So we'll always start at generate filters. We'll always finish at filter data. Filters will get passed to chart type will get passed to data format, and display data format will get passed to filter data. And then once this is all finished, we compile our graph and assign it to this graph variable. This is because we're using LangGraph deploy, and LangGraph deploy needs to know exactly where to find the compiled graph, which it can then use on the cloud. So we have this langgraph.json file, and this is where we define our LangGraph configuration. So we list our dependencies. In our case, it's our GenUI backend directory, and we have a requirements.txt file here, which lets LangGraph know what requirements or what dependencies to install on the server. And then we have this graph dictionary, and this graph dictionary contains all of the graphs we want on our server. So in our case, we only have one, but you could have as many as you would like here, and they just need to map to a compiled graph. So ours is named GenUI graph, and that contains a file path, GenUI backend, charts, chain, and then the name of the variable which this compiled graph is assigned to. And then for local testing and development, we specify where our environment variable folder is, or file is, but we're not going to do anything local here, so we don't need to worry about that. Okay, so now that we've done that, we can get into the actual code behind the nodes. So let's take a look at our first node, generate filters. Here, we see it takes in the agent state and returns agent executor state. Here, we're only returning one field, and that's because LangGraph allows us to return a single field of the state, and it will either append or update that field to the full state, and then pass the full state with that addition or update to the next node. So here we get our state, we define our prompt. Our prompt is pretty simple. You're a helpful assistant. Your task is to determine the proper filters to apply given a user input. The user input is in response to a magic filter prompt. They expect their natural language description of the filters to be converted to a structured query. We then get all of our product names. So using our state.orders field, we extract all of the product names, convert them to lowercase, and then pass that to our filter schema function. This function takes in our product names and then returns a new Pydantic class filter schema. And you'll recognize these filters all correspond to the filters we saw on our front-end dialog. And that's because these are the filters the LLM can select. They're all optional because the LLM does not necessarily need to select a filter. But if it wants to, it can select something like the product names to filter by specific products, statuses to filter by one or multiple statuses, minimum discount percentage, and so on. So we get our schema, and then we instantiate a new chat OpenAI class. You can use any chat model which supports tool calling. In our case, we're going to be using OpenAI Turbo because it's quick. And then we pass with structured output our schema, and that binds this tool to our model and forces our model to invoke that tool. Using the LangChain expression language, we pipe our prompt to our model, and then we invoke our chain. This invoke call, if you're not familiar with LangChain expression language, real quick, it just invokes our prompt to pass in this input field, which is what we're passing as our human input, and that's going to put whatever content, which in our case is the magic filter input, it's going to pass it to this field, convert this to an OpenAI compatible format, and then pass that to our model where it's going to hit the OpenAI API and get us a response. Since we're using with structured output, that already contains a tool parser, so the result is going to be already parsed into just the tool call. We can update our selected filters state field with the selected filters if any were passed. The next 2 or 3 nodes, we're going to kind of blow through them because they're all, as we saw in our diagram, pretty similar to the first, just an LLM call with a unique prompt, output parser, a schema, and then we return the type. So generate chart type takes in our state. This prompt is a little bit more complex. So we say you're an expert data analyst. Your task is to determine the best type of chart to display the data based on the filters and user input. You're provided with 3 chart types, bar, line, and pie. The data which is being filtered is a set of orders from an online store. The user has submitted an input that describes the filters they'd like to apply to the data. Keep in mind, each chart type has set formats to display the data. We saw this earlier with our display data formats. So we tell the LLM you should consider the best display format when selecting your chart type. Then we pass it those data display formats. This contains the key, which it can use later to reference the data, the title of the format, and the description. The LLM then uses this and the bar, line, or pie chart to select the best chart based on whatever the LM format it wants to then render the data. We also pass it the selected filters which have been generated and the magic filter input from the user as extra context. We then have our schema, which contains the chart type, just one of these three, and the LLM is going to then pick one of these to render the data on. Pass it to our model, invoke our prompt, and then update the chart type state field. Next, our generate data display format. We know what the chart type is, so we say you're an expert data analyst, and we basically tell it you need to pick the proper data display format based on the chart type. We pass in the extra context, and then we define our display key, which contains a description saying the key of the format to display the data in must be one of, and then we just join all of the different keys from the display formats which match the chart type. So this display format schema contains the title, which is, for example, this, the chart type, bar, line, or pie chart, the description, which would be one of these, and then also a key, which is some unique key we can use later on to identify which data display format was selected. So getting back to our node, we pass all that through, and then the LLM will select the best data display format, which it deems is the best way to render the data for the user. We invoke our model and then update this data display format state field in our graph with whatever the LLM selected. Finally, we have our filter data node, which just takes in the selected filters from the state, any orders which we passed in originally, and then we just have some if-else statements which filter out the data, and if it managed to get past all the filters, we append it to this filtered orders list, and then finally return via the orders field, and that's just going to overwrite the orders field, where originally it was all of the orders, but here it's going to overwrite that to only the filtered orders. That's it for our backend. Now we can look at exactly how we would deploy this to a fresh LangGraph cloud app, and then connect that to the front end, run it, and look at some more demos. So you're going to want to find your LangSmith app. If you're not already on LangSmith, I'll include some links down below where you can sign up. And then you want to click New Deployment. Your screen will probably look a little bit different than mine if you don't have any deployments already, but this New Deployment app should be pretty much in the same place. So you click New Deployment, and then you're going to want to connect your GitHub account. I've already connected mine, and then you just select a repo. So I'm going to want to deploy our GenUI Python app. I do that, and then I add a name. Test deployment. This is a path to our langgraph.json file lives. In this repo, it lives inside the backend, so backend, and then a Git reference. I am going to be specifying a custom branch because I have some changes which aren't merged to main, but this could be any Git branch that you have. So add your Git reference. In my case, it's brace/improved viz, and then this is the deployment type. I'm just using development, so I select development, but if you're going to production, you're going to want to select production. Oh, I got rid of it. Open it back up. It's all pretty much saved. Test deployment, got to add that back in there. And then environment variables. This is where you add any environment variables you might need for your app. So I'm going to add my OpenAI secrets and some other things, and then we'll come back. So I've added my OpenAI API key, and then I add a tracing project, and this is where all of the runs from this app will get sent. So I don't have a test deployment tracing project yet, so we're just going to use the default name it selects, and hit submit. And now I've submitted my deployment. It's going to load and then try and deploy, or not try, it's going to deploy my app. This is going to take a few minutes, so I'm just going to use the deployment that I already have, and we can see how you would connect that to your front end, and then actually make API requests to it. Okay, so now we're at my deployment. We can see my deployment is currently deployed, and we have this API docs link right here. We can click on that. While you're here, you can look at any API endpoints you might want to hit, but in our case, we want this base URL. And this is the URL which we're going to use to connect to it. Below it, we see this API key. This is a normal LangSmith API key. You can generate those in your settings of LangSmith. And we're going to want to pass that under a custom header via X API key. So once you have your API key and your URL, in my case, I wanted to set them as an environment variable. So I've set my API URL under the LangGraph Cloud API URL, and then my API key under LangGraph Cloud API key. You're going to want to instantiate a new instance of the client from the LangSmith or LangGraph SDK. So you have imported client from LangChain/LangGraph SDK. And then I pass in my API URL and my default headers containing my API key. this is going to be the SDK we're going to use to connect to our backend and make API requests. So you can see the first thing I do is I search for my assistants. LangGraph deploy offers a whole lot of features around stateful threads where you can revisit certain steps and persist the data that were in them. In this case, we don't really need any of our previous threads or runs, so I just grab the first assistant. And then I have this runnable lambda. The reason I have this runnable lambda is because the stream runnable UI function we use to stream the UI components to the client requires a LangChain runnable to invoke as the API. The LangSmith SDK does not contain a stream events endpoint, so I wrap it in a runnable lambda called client.runs.stream, which is going to hit my LangGraph API and stream back events the same way. And then I just yield each of those events as they come in. And I'm yielding that inside of a runnable, so I can pass it to my stream runnable UI, call stream events on this runnable, and extract all of these events in the same way I would if I were just calling stream events. Important to also apply this run name, and that's because there is one small little implementation detail we don't need to worry about inside stream runnable UI, and the name needs to line up with whatever name you've assigned to your runnable that's wrapping your LangGraph SDK stream call. Then, as you can see right here, we have the stream runnable UI. If you watched our previous videos, you're familiar with this function. We went into detail on exactly how it all works. Here, we're not going to do that, but you should go check out those videos. We're passing in our runnable the inputs, which we got from our front end, which contain the content and then orders and display format. And then our event handlers. These event handlers are what's going to be called each time an event is yielded in our stream events call. So in our case, we just have one event handler 1. In here, we get our stream event, which is each event that's yielded. And then fields. These fields contain this UI field and callbacks. We only care about UI here. This UI field is from the AI SDK, and it's what allows us to update the UI using React, and they do some heavy lifting under the hood we don't need to worry about. So then we iterate over all of the events. We only care about the event if it's on-chain end. And that's because LangGraph and LangChain stream events are going to stream events for everything that happens in this graph. So we can get an on-chain start, some events inside the chain, and then on-chain end. In our case, we only care about on-chain end because we only want the results of each node. So if the event does not equal on-chain end, then we return. Next, we say if the name is generate filters, and these names are all going to correspond to whatever names we gave our nodes in the backend. So if the name is generate filters, we're going to get the filters that were applied and call this handle select filters function. This handle select filters function is going to map over all of our filters and assign the value of that filter to this filter button, which is what we see on the front end right there. Then when it's done, it calls UI.update, and this is going to actually update the UI with these filters so that the user can see them right away as soon as the filters come in. All of these functions do something pretty similar to that, where they take the result of a chain output, and then they update the UI with some data. We can jump right to the last one, where we iterate over our bar chart type. This display data object contains a props function where we pass in all of our filtered orders, and that formats these orders in a way which can be passed to bar chart, pie chart, or line chart. We then assign our bar chart variable either bar chart, pie chart, or line chart, and then we update our UI with, as we saw, the title of the display format, the description, and then the bar chart. This is already there, and we don't need to update or append this again, because when you call UI.update, all it does is replace the last JSX element which is updated in the UI, or you can call UI.append, which will add a new JSX element to the UI that we're updating, and we can no longer update the first element. So when we added our first buttons right here, we called UI.update, and the next time we added some UI element, we called UI.append, and that will set this in stone, and we can't touch that again. So we call UI.update, and that adds our bar chart, and it replaces whatever was there before. In our case, it's going to be that loading component, which is going to get replaced by this update call. And then finally, it finishes and gets rendered to the client. So if we go back, we can look at a couple more examples, and then we can look at the LangGraph Cloud Playground, which is how you can test this and iterate on things in development. Okay, so we're back on the UI, and we can look at our display types modal, which will show us all the different ways we can render this data. And let's say we want to see our weekly order volume. The x-axis is the date, and the y-axis is the number of orders. This chart will show you the trend of order volume over time and allow you to identify peak ordering weeks. That seems interesting. So let's say orders by week after 2023, 10/01, and with an order price of more than $200. We'll hit submit. We'll wait for it to load. We see our after date 2023 10/01, and then our minimum amount to filter by is 200. And there we go. We have our bar chart. As we saw here, we wanted a bar chart, and the x-axis are the dates. Let's see if that lines up. Yep, dates, and the y-axis is the number of orders, and that makes sense. We can see each week, this date is going to be the start week, and the number of orders. Now let's go take a look at another type of chart we can request and see if we can get it. So we open up our display types modal. Let's scroll down. Let's say we want a pie chart. How about quarterly order distribution? Groups orders by quarter using the ordered at field. So let's say, show me orders by yearly quarter. Hit submit. Wait for it to load. I don't think we should have any filters. So yeah, we have no filters right here, and it selected our pie chart just like we wanted, and it shows us all the orders in a specific quarter. So now that you can see how that works, we can go take a look at the LangGraph Cloud Playground and see how you can invoke this in sort of a development mode and iterate on your LangGraph graph a little bit more. So we go to LangSmith, go to our deployment page, and then we click Playground. Open this up in a new tab, and here we see we have all the different nodes. These nodes are drag and droppable. We can hit this to add interrupts markings so that when it reaches this node, it'll pause. We can look at all of our previous threads, we can create new threads, and we can actually invoke our chain. So I'm going to paste these inputs in because they're kind of long, and we'll come back once they're in and we can submit it. Okay, so we're going to place an input which says orders by week after this date with a price of more than this price. I've added my display formats because these are also what is passed to the chain we first invoked in the client, and then also our orders. These are all, I just copy pasted them. Once those are all in, we can hit submit, and we should see our graph executing in real time right here. So submit, it loads, and then boom, it's flying through everything. We can see over here as well exactly what nodes it's hitting, and when it's done, it exits out there, and we can actually go and look at all the different nodes and the outputs from each node. So filter data returned orders, generate data display format returned the display format, chart type returned the chart type, and so on. So we can see exactly all the filters which were applied to these, and it just gives us a much better idea as to what's going on inside our chain. We can do certain things like edit those fields, we can run from specific nodes with different results, and we can see how our graph reacts and acts based on different inputs, and it can give us a much quicker iteration cycle because we don't need to hit the entire API at once or go and modify the code like that, because we can just edit the inputs and outputs and rerun from right there. That's the end of this video. I hope you guys all have a much better idea as to how to build a generative UI application like we saw here. I hope you have a good idea as to LangGraph Cloud and go try it out on your own. It's a lot of fun to build with LangGraph, and now LangGraph Cloud makes it so much easier to deploy to production. And I hope to see lots of interesting and fun generative UI apps running on LangGraph Cloud in the future. See you on the next one.